let's work practice problem 5.1. So I've already drawn the circuit. We have an op amp. It says it's a 741, so that's just a particular type of op amp that you could find in the stockroom. A 741 has these parameters, so that's just straight from your textbook. Has a gain of 2 times 10 to the 5, an RN of 2 meg, and an RO of 50 ohms. And then we have not drawn the power supplies on here just because it clutters the circuit. So remember that they're always there, but we don't necessarily draw them when we're solving a circuit problem. So we're asked to find VO, which is out here, over VS when this current, and this current, when our source is 1 volt. Okay, so the only way we know to do this right now is to use the equivalent circuit. So we're going to replace our op amp with that equivalent circuit that we drew in the lecture. So our equivalent circuit for an op amp looks like this. You have your RI. RI here is 2 meg. Then you have your voltage dependent or voltage controlled voltage source. This goes to ground. And then you have your RO, which is 50 ohms. This is RI, and this is AVD, where now I'm a little cluttered over here. Let's see if I can get rid of that without making too much of a mess. VD is right here, and we'll just say RI equals. Okay, so that is my op amp. That is here. So at the plus, I have this voltage source. So I've drawn that in. That goes down to ground. At the minus, I have 5K. That goes down to ground. I have 40K. That goes like this. And then I have a 20K that goes between ground and that output node. There's the 20K, outputs across there, and here's my output location. So this is my circuit, right? This is the exact same thing as that, except I've replaced my op amp with that right there. Okay, so it looks a little crazy, right? But we can draw this a little bit nicer if we want to. These two are just in series. So I can draw my VS here with that 2 meg in series. That goes to a 5K, right here. So think in terms of nodes. So we've made that node. That connects to a 40K. That connects to a node that's here. And there I have a 20K down to ground. And a 50 ohm. And I don't know why I drew ohm because I haven't drawn it on any other ones. Let's fill them all in. There we go. Ohms everywhere. And that connects to this source. And I have a value for A, I'm just not writing it in because it's so big. And then I have to remember to define where VD is, and that's across here. So these two circuits are equivalent. It's just a lot easier to visually handle the circuit this way. Okay, so now we just need to solve. So I'm going to go ahead and call, it says for when VS is 1 volt, so I'm going to go ahead and put that in here, 1 volt. And I'm going to go ahead and call this node V1. And my output I need to draw, that was across the 20K resistor. That's right here. So I might as well go ahead and call this node VO. And then of course this is a VD. So we're looking for voltages. Usually when we're looking for voltages, it's easier to do nodal. So we're going to go ahead and do nodal on this. So I have V1 minus 1 over 2 meg. plus V1 minus VO over 40K plus V1 over 5K equals 0. And did I reduce that down? I don't think I did on this page. Let's write nodal for here. It's VO minus V1 over 40K plus VO over 20K plus VO minus AVD over 50 equals 0. My VD is right here. That's going to be 1 volt minus V1. So I can replace VD with 1 minus V1. So now I have two equations and two unknowns, VO and V1. I'm not going to do the algebra on that. I'm going to trust that you can do it. If you do this, you get VO equals 8.99959 volts. There's a reason I'm writing it out this way, and I'll show you that in the next video. V1 is 0.99995 volts. And then my VO over VS that they asked for, let's go ahead and say that's approximately equal to 9, because we have 9 over 1. When we talk about gain, you can write volts per volt to remind yourself it's a gain, or you can write no units, right? Because volts over volts is unitless. But sometimes we write that just to remind ourselves that it's a gain. And our current then, I.O., so I.O. was coming out right here. It means I.O. is here. So I.O. is across our 50 ohms. So I.O. is equal to the voltage on one side, VO, minus the voltage on the other, AVD, divided by the resistance, right? That's just Ohm's law. I equal V over R. And I have all of this now. So I can do that, and I get 0.64997 milliamps. Again, I've written it out like that for a reason that will appear in the next video. So take note of those numbers, and we're going to find an easier way to do these problems.